Hi everyone and welcome to Microsoft Build 2017. My name is Mikkel Mark, and in this video I'm going to walk you through how to get your ASP.NET 4 applications running in containers in Azure. We know there are a lot of .NET Framework applications out there today that have been built over the last many years. We also know that a lot of these applications run in data centers today and in hosting environments where it might be difficult for you to go and implement modern DevOps practices. I want to show you how we made it very easily with our developer tools and services to take those .NET Framework applications using container technologies, get them up and running in Azure in some hosting environments that are great to start getting on a path of implementing modern DevOps practices. So let's head over to Visual Studio 2017, where I've opened an application project that we published back with the Visual Studio 2013 launch. This is called My Company Visitors Web. And it's a simple web application with an API and a single-page application client UI and a few class libraries to help support the application. As you would expect, I could go ahead and debug this in IIS Express in Visual Studio 2017. But I want to really get this into a container to make those dependency isolation and make it very easy to go and deploy into the cloud and operate in a modern way. So within Visual Studio, I simply right-click on my on my project, and I go ahead and I add Docker support. When we add Docker support to a project in Visual Studio 2017, we're adding a few files to use to this project. First of all, we're adding a Docker file to my web application. This Docker file describes how my container image is going to be built once we run our Docker commands against this file. Now, Visual Studio knows that this is an ASP.NET Framework application that needs to run in IIS. So we go and identify the image that we want to build this container upon, which is the Microsoft/ASP.NET image. These Microsoft ASP.NET image is one of the container images that Microsoft maintains and publishes into Docker Registry, which is publicly available to anyone. You can even go into GitHub and find the Docker file that describes how this image was built. So when you're building on top of this image, you're basically creating another layer on top of an image that we already created for you. And that makes it possible for you to also go in here and change whatever configuration you need in that container. So let's say you have special dependencies you need to deploy into the container to get your application to run. You would just go ahead and describe it right here in the Docker file to run some PowerShell commands or enable more Windows features that your application would need. So now that we have the Docker file described, which tells how to build our container, we also introduce Docker Compose files into your solution. A Docker Compose file is a way of describing how to run containers. And what you see in this file is that we're referencing a container image, which is the name that we will give the container image because we will be using the project name that you have in Visual Studio. What I can do is in my Compose file here is I could go ahead and specify the ports that I want to expose on my container host to make this container reachable from outside the container host. So in this case, I know my container listens on port 80 on the internal network that runs within the host where the container sits, but I want to map that port to the host port 80 so I can reach this web application from any client outside the host. This is what I'm doing with my Docker Compose files. Now I'm actually done in Visual Studio. I'm ready to go ahead and package this application into a container, and I can take that container and run it anywhere where I can run containers today. But before we go there, I want to show you when this becomes really powerful in an application development scenario. So let's say this application, which is an application that's made to simply register visitors that we have in our company. I want to expand this functionality a bit. So I want to show some of our CRM data that we have around the visitors when they come and visit our company. Instead of extending on the existing application that I already have, I can actually now go and add a new project into my solution and run that in a separate container. And because those are separate containers and because there's isolation between them, I don't have to stick to the technology I used to use or the frameworks I used to use in the first part of the application. So in this case, I could go ahead and I could actually create an ASP.NET Core application. We can call that the CRM service. So let's say we want to do a web API here. To simply sit as, you could imagine this be a service that sits between the application that I already have and some backend CRM system, and expose a web API to easily get information out of my CRM system. So now that I have my application in here, and I've chosen it to target Windows because this is .NET Core, you will see that my Docker Compose file is now being edited, and this new service that I added into my solution is now part of the Docker Compose file, meaning that whenever I want to run these containers, both containers are being run in unison in my container host. You can also see from the Docker file in my ASP.NET Core project that this is optimized to run on a .NET Core image running on Windows Nano Server, which is far more agile and smaller than the Windows Server Core, which needs the full .NET framework. So again, I can go and expand on this Docker file. If I need to maybe expose my web application on another port, I can make all of these configurations here in my Docker files. So let me shift over to a Visual Studio version I already have running, where I actually have set up these two applications. I've done my coding, and I've already started a debugging session. So I want to call out a few things here that makes it very, very easy to work with these with containers or services deployed in individual containers in Visual Studio. So what you see here is my Docker Compose file, and you can see I have the two services specified here, and I have exposing ports from each of them. What I have on my left-hand side is the controller in the old application that needs to communicate with this new service that I have in my new container. The way that the way that my Docker Compose file is set up, I have a service name specified in here. That service name gets registered in the Docker host DNS. So it's actually as easy as just calling out the service name from my Docker Compose file from within my code to make this container-to-container communication. So let me shift over here, and I've set two breakpoints. So on the left-hand side, I have a breakpoint in my first service. On the right-hand side, I have a breakpoint in the other service. And I already have the application running here, and you can see it's 172 address, which kind of hints to me it's the internal network for my containers running. And when I go and hit the functionality in the application, you can see I hit my first breakpoint on my left-hand side. And when I continue, I actually hit the breakpoint in another container, the .NET Core container, also running on my host. So it's very easy, even though I have multiple containers with different technology running locally, to still get the debug experience and the very efficient inner loop that you are used to expect from Visual Studio. So now that we got the application all set up, we got it Dockerized, and we even extended it, even though we didn't have to, we want to get it up and running in Azure. So from inside Visual Studio, I can easily configure continuous delivery if I have my application already checked into a remote repository. Now I did that already, and I want to take you to Visual Studio Team Services to see how this is set up for you. So in Visual Studio Team Services, we've introduced some build and release definitions that makes it very easy to take these containerized ASP.NET Framework applications and get them into the cloud. So the build definition I'm showing you here is doing NuGet restore and build solution like you would do with any ASP.NET Framework application today. Now, in my experience, since you're bringing over some older .NET Framework applications, you might need to tweak the NuGet restore and the solution build to support your application. But I'm confident that you know your applications better than I do, so you know the tweaks and twerks you have to do there to make that all work. What's new in here is how we build your Docker images and pushes them into a Docker registry. So there are 3 Docker Compose tasks that we set up and that we would recommend that you're doing. First of all, we'll go ahead and build your Docker images based on the Docker files. Then we'll push those images into a registry. And in this case, I'm using the Azure Container Registry, which is my private container registry that I've secured using Azure Active Directory authentication, which makes it very easy for keeping these containers, container images in a secure place in Azure and made available for my container host to run. The final step we're doing is what we call log service. So when we build containers, we give them an image name and we give them a tag to give them an easily readable way of identifying the version of that container. Now, tags aren't necessarily mutable. You can easily override a tag with new content without that being the same version. So instead of putting on the path of using those tags, what we're doing here and what we're recommending you to do is to take the actual digest or the the hash of the image layer that has been built, and using that to reference that specific image in your Docker Compose file. Might sound a bit complicated, and whoa, why do I need to do that? But cool off, we got a task already configured that just does this for you. You don't have to consider this. I just wanted to make sure that you understand what we're actually doing here. So that's what we mean by locking your service, making sure you actually get the image that you just built and not some random image with any image tag on it. So finally, our build definition is publishing the Docker Compose file, which is now what we need to hand over to any of our container hosts to actually go and run these containers. So let me switch over to my release definition. There are many places where you can run containers in Azure today, and different container hosts and orchestrator technologies out there. Service Fabric is one of them, and Service Fabric has been running a lot of Azure services throughout the years and proven its value in a high-density, high-reliable environment. Service Fabric is running Windows containers on Windows hosts today, but what Service Fabric has also introduced is the ability to go and deploy containers using Docker Compose files, which just makes this very, very easy to take what I just created in Visual Studio, build in Visual Studio Team Services, and now go and push into the cloud into a Service Fabric cluster. So all that I have to do in my release task is point to the Docker Compose file that we just created in our build definition, which then specifies the container images that now sit in my Azure Container Registry, and create an application in Service Fabric based on the Compose file. So let's head over to the Azure portal, where we can see the actual Service Fabric cluster now running. I have a 5-node cluster here, and you can see I've had 3 applications deployed to it. Because of the isolation and the isolation that containers gives you in terms of dependencies of individual applications, you can easily see that 30, 40, 50, or even 100 applications running in clusters like these. It's only a matter of resources. There will be no dependency conflicts between these applications, as everything is contained within the containers. So now that we got things running in Service Fabric, so here you see Service Fabric Explorer, which is the way I can go and interact with my Service Fabric cluster through a nice web UI. You can see I have my 3 applications running. And what I want to show you is how easy now that I have this container running in a high reliable cluster, I can scale out the number of instances of my container running, and I can easily fail the container over in the case that a node needs to be taken down or some failure occurs. So you'll be able to see here from my application that I have 1 instance of this container, the web container. Right now I have that running in my cluster, and it runs in a node called default3. So we can go ahead and we can take down this node just to simulate that we had a failure occurring in the cluster, or if we wanted to take it down for maintenance. And as my node is now disabling, you will see that my container instance now is being spun up on one of the other nodes that's available in the cluster, making sure that we still have this 1 instance of running in the cluster. I can also easily scale the number of instances that I have in my cluster. In this case, I'm going to spin up another instance, and you would see again on the left-hand side, the cluster will go and pick a node that has the resources available to run that extra instance of my application. So now I have my application running across 2 instances within 2 nodes within the cluster as 2 instances. So let's just pause for a second and appreciate how easy this is when we have containers and we run in these high reliable clusters in the cloud. Just imagine what you would have to do with this if you were running this application in IaaS in any data center today, setting up new hosts or even new virtual machines, getting all dependencies configured and deployed into the cluster, into that host, and then start running your application. It's much more easy now that we have containers and now that we have orchestrators to actually go ahead and do this. So our application is up and running in the cloud. We got the high availability, we got the high density configured. Let me show a bit of how the Azure Monitoring and Azure Monitor and Application Insight also understands and helps you operate these containers or applications now running in containers in the cloud. So I've switched over to the Azure portal now, and I've set up a dashboard with a lot of information about my container. You can see the different resources that I have running, and you can see in the bottom line some information about performance and the resource uses on the host that I have. But I also want to call out that Windows Azure Diagnostics is now able to give you statistics about the CPU utilization of the actual containers running in the host. So not only can we tell you the resource uses across the hosts in Azure, we can also look at how the individual containers within the host are using resources and report that back to you here. I also want to call out the application map and application insights, and how application insights now understands how different services and different containers communicate with each other. So what you actually see on my application map is you see the first service, or the first web app that I containerized, and you see my new CRM API. And you see how the dependencies goes from one container to the other. And from this application map, I can easily drill into the individual containers, and I can go and look at some of the failed requests that has happened between them, and get some great diagnostics and insight in helping me figuring out what's actually going on and what needs to be fixed with my applications. So this was a race through a lot of different features and a lot of different technologies we've given you to make it very, very easy for you to take these ASP.NET Framework applications that you have today, running around your data centers in various configurations, helping you picking these up and getting them into this modern DevOps workflow by using containers. And the way we made it easy is with Visual Studio 2017, container tooling, and the integration into Visual Studio Team Services to easily get you on a path for continuous integration and delivery. And finally, have those containers running in an orchestrator in Azure, like Service Fabric, that gives you the high density and reliability that you would expect from any cloud hosting environment. Now, a few call to actions the last time to finish up with. So go and get Visual Studio 2017 Preview 3, which has the latest container tooling and better support for Windows Nano Server. And just get your app. You know where it is. You know where those framework apps that you have are. Start getting them into Visual Studio 2017. Start containerizing them today. And see if you can get them run locally. And once you have it there in a container locally, it's very easy to take them into the cloud and take them into Azure. Thank you.